So I wanted to start out by reviewing just our basic operations with decimals today. So in the first one here, we're adding. Now in adding and subtracting, remember, our big rules are we must have the same name, and then once we combine the counts, we keep the same name. So when we add or subtract, when we set it up, what's the big thing that we must be sure to do? Line up the decimal point. So 47.38, the decimal point on the number below it has to be directly below that decimal point there. So 9.642. So my decimal points are lined up. Now I have to make sure I fill in that missing decimal place there so that everything is filled out. And now I can go ahead and start to add. 0 plus 2 is 2. 8 plus 4? 12. So 2, carry the 1. 1 plus 3 is 4, plus 6 is 10. So 0, carry the 1. Now before I can do that next column, I have to bring down the decimal point. 1 and 7? 8 plus 9? 17. So 7, carry the 1. And of course 1 and 4 is 5. So 57.022. When we multiply or divide, remember, we do not have to have the same name. And once we combine the counts, we are also going to combine the names. So up here, do we have to line up the decimal points? No, because when we multiply or divide, we do not need the same name. When we do the multiplication, we totally ignore the decimal points, at least at this point. 4 times 7, 28, so 8, carry the 2. 4 times 8, 32, plus the 2 is 34, so 4, carry the 3. And 4 times 3, 12, plus the 3, 15, so 5, and we carry over the 1. Now I'm going to put in my 0 down here, and I'm going to put a line up here. And I'm moving over to the 5. 5 times 7? 35, so 5, carry the 3. 5 times 8? 40, plus the 3? 43, so 3, carry the 4. 5 times 3 is 15, plus 4? 19, so 9, and we move over the 1, carry over the 1. Then we're going to add 8 and 0, 8. 4 and 9, or 4 and 5 would be 9. 5 and 3, 8. 1 and 9, 10. So 0, carry the 1, and 1, 2. Where does my decimal point have to go here? 0 and the 8. Very good. Because we have 1, 2, 3 decimal places in the problem, we have to have 1, 2, 3 decimal places in our answer. Again, that's just combining the names. Hundredths times tenths is thousandths. So that's 20.898. Any questions so far? Number 3, when we go to subtract, what do we have to make sure we do? We line up our decimal points. Before we can start subtracting, what do we have to do? Put in those missing zeros. And now, of course, we go to subtract. 0 minus 8 can't be done. So we do have to borrow. And I know some of you have learned the subtract 1 or add 1 to it and subtract it. I'm going to borrow from the 3 here. That's a 2. This is a 10. Now I need to get all the way down here, so I got to keep borrowing. I'll borrow from that 10 to make a 9. And another 10. Borrow from that 10 to make a 9, and that now is a 10. So now we subtract. 10 minus 8. 2. 9 minus 3. 6. 9 minus 7 is 2. 2 minus 6. We do have to borrow. So this becomes a 1, and this is 12. 12 minus 6 is 6. What do I have to do before I can do the 1 minus 8? I bring my decimal down, and then I have to borrow from the 7. This is a 6 and 11. 11 minus 8. 3 and the 6. Any questions there? Okay, so over here, 37.58 divided by 1.8. I'm not actually going to do 37.58 divided by 1.8. What am I actually going to do? Perfect. Move that decimal point over so that I'm not dividing by a decimal. To make that happen, I got to do the same in here. Remember, we think of that like a fraction. What we're really doing is multiplying both the top and bottom by 10. So the decimal point has to move one spot in both numbers. So this is now 375.8 divided by 18. So now, does 18 go into 3? No, so I'll leave it blank above the 3. Does 18 go into 37? How many times? 2 times 18 would be 36. That leaves us with 1 left over. What do I do next? We bring down the 5. Does 18 go into 15? No, so what do I have to do? Let's put a 0 above the 5. Because I've used the 5, I have to have something above it. Can I bring down the 8? Not yet. What do I have to do? My decimal point has to go up first. Then I can bring down the 8. 18 into 158. 8 times, 18 times 8 is 144. This is 14. Am I all done now? I'm out of numbers. I can actually add a 0 in there and bring that down. Remember, after the decimal point, if we're out of digits, we can add zeros. 18 into 140, 7 times. So we 126. That's going to be 14. Add another 0. Good. But we said to the nearest hundredth. Aren't we to the nearest hundredth there? Yes? So do I still need that other 0? Yes, I do. We have to go, always have to go 1 past. So 18 into 140 still goes 7 times. So to the nearest hundredth, the hundredths place is this digit right here. That's a 7, so what does that tell us to do? Round it up. So it's 20.88 is that to the nearest hundredth. Now in this problem, something occurred here that occurs quite often that we need to figure out how to deal with. I had 140 here. I had another 140 here. Well, 7 times 8 is going to be 126. It's going to be 14 again, and when I add a 0, it's going to be another 140. It's going to keep being 140 divided by 18. So what's going to happen up here if I were to keep going? It'd be 7, 7, 7, 7, 7, 7, 7, 7, 7. Yeah, it's going to keep going. That's what we call a repeating decimal. A repeating decimal can be one number, or it can be several digits repeated over and over again. Here, that's just the 7 repeated over and over again. So the way we could write, now in this one I asked you to go to the nearest 100. So rounding it like we did here is the correct way to express that answer. But what if I said, give the exact answer? Well, the way we express that 7 repeats is this. It's 20.87. And once we've written all the digits that repeat, and the 7's the only one that repeats, we put a bar over it. That bar tells us that 7, and only that 7, keeps repeating over and over again. So let's look at some examples of that. .834 divided by 1.1. First of all, when I set this up to do my division, what's actually going to go inside here? Yep, but instead of 2.8, it's going to be perfect. I moved this over 1. I had to move this over 1. So 28.34 divided by 11. So now does 11 go into 2? Oh, 11 doesn't go into 2. So we leave it blank above the 2. But 11 goes into 28, and you're twice. So we put the 2 above the 8, because it's the last digit we used. 2 times 11 is 22, leaving us with 6. Now what? Move the decimal point up. And then? Bring down the 3, okay? 11 goes into 63. 5 times. 5 times 11 is 55. That's 8. And then? Bring down the 4. 11 goes into 84. 7 times, that's 77. We subtract there, we get 7. And then? Add a 0. 11 goes into 70. 6 times. That would be 66. We subtract to get 4. Add a 0. Notice I didn't say go to the nearest anything, so we're just going to keep going until we find a pattern or run out of paper. So add a 0 and bring it down. What happened? What do I get? 11 goes into 43 times. That's 33. What's going to be left over? 7. Add a 0, bring it down. 11 goes into 70. 6 times. Now at this point, this is probably about the earliest I could see this, but I see this developing. This is a 70. This is a 70, right? I'm going to get the same result. Every time 70 is divided by 11, I'm going to get the same result. So I got 6, 3. If I keep going here, 6 times 11 is 66. I'm left with a 4. Add a 0. It's going to be 40 divided by 11, which would be 63. There's 3 again, right? So I can see here, starting at this point, the 6 and the 3 just repeat over and over again. So that answer, 2.57, then the bar goes above the 6 and the 3. Yeah, all those repeat. I'm going to have you try one in your notes. See if you can find the repeating pattern here. 45.38 divided by 1.4. Now I'm going to pause and see what you guys come up with. Let's see how you're doing here. So we've got the 45.38 divided by 1.4, which of course is going to become perfect. 453.8 divided by 14. Does 14 go into 4? Nope, so it stays blank above the 4. 14 into 45. 3 times. 3 times 14 is 42. Leaves us with 3. Then what? Bring down the 3. 14 into 33. Twice, that's 28. So 5 left over. And then decimal point goes up. The 8 comes down. 14 into 58. 4 times would be 56. That's 2. Add a 0. 14 into 20. Once. 14, there's a 6. And a 0. 14 into 60. 4 times 14 would be 56. This is with 4. Adding a 0. 14 goes into 40. Twice. That's 28. Leaving us with 12. Adding a 0. 14 goes into 120. 8 times. That's 112 with 8 left over. We add a 0 and bring it down. 14 goes into 80. 5 times. 5 times 14 is 70. That's 10 left over. We add a 0 and bring it down. 14 into 100. 7 times. So that's 98. 2 left over. Now at this point, I see there was 2 left over, and way up here there was 2 left over. So it's going to be 20, and then it's going to be 20 again. So it's going to start over. That 20 is what gave us this 1 here. So these digits are going to repeat over and over again. So the solution there is 32.4 and then 142,857 with those repeating. Any questions? That one's kind of mean to have it that deep into it, to go 6 digits to repeat. I have to entertain myself somehow. Okay. Now the other thing I want to look at is, what if I am dividing something like this? 7 divided by 30. Does 30 go into 7? No, it does not. So I got to leave that blank there. But there isn't a next digit here. So what I have to do is add a decimal point, and now I can add that 0. My decimal point has to go straight up. 30 does go into 70 twice. 2 times 30 is 60. Leaves me with 10. I can add another 0. 30 goes into 100. 3 times 30 is 90. Leaves me with 10. I can add another 0. 30 goes into 100. 3 times. Okay. So we see it happening here. That's going to repeat. So that is 0.23 with the 3 repeating. The reason I wanted to show you this, where we had a smaller number divided by a large number, even though there was no decimals in this to begin with, we ended up with decimals in our answer, is because if I have a fraction that I want to convert into a decimal, the way we did that is to divide the numerator by the denominator. 5/8 to convert that into a decimal becomes 5 divided by 8. Now last week we saw that briefly, but we had to do it on the calculator because we didn't know how to do it out by hand. Now we know that is 5 divided by 8. 8 does not go into 5, so we have to add our decimal point, bring the decimal point up, add the 0. Does 8 go into 50? Yeah, 6 times 8, 48. That leaves us with 2. And then add a 0 and bring it down. 8 into 20. 2 times 8, 16. Leaves us with 4. And then add another 0 and bring it down. 8 into 40 is exactly 5 times. So that one doesn't have to repeat. It actually is what we call terminates at 0.625. I am going to have you do, in your notes, 7/12. Convert it to a decimal for me. So, it's just going to be 7 divided by 12. Tell me what to do. Okay, we had the decimal. Move it up. Add a 0. 12 goes into 75 times. That's 60. The 0 and bring it down. 8 times. 96, that's going to be 4. Add a 0 and bring it down. It's going to go in there 3 times. That'll be 36. That'll be a 4. Add a 0. That's 40. There we go. That 3 is going to repeat. So 0.583 with that 3 repeating. Any questions? Better than a sharp stick in the eye? No?
I like those.
Okay. Take out the variables, it's not so bad anymore. Well then, I hate to do this to you. Sorry, but there's our next step, of course. Now looking at this one here, again, it looks more difficult because of the decimals in it. But this is no different from when we had 3x minus 7 equals 14. How did we solve this one?
8.4 to both sides.
Okay, perfect. We added first, yep.
Right.
So you're right, we're going to add the 8.4. So 4.2x equals 10.5, and then divide by 4.2. X equals 2.5. Any questions there so far? So then in an equation like this, what would we have to do?
Subtract the 3.7.
We're going to subtract 3.7. So 1.4x equals 5.4, right? Then what? Divide by 1.4. So x equals 3.85714.286, correct? Otherwise known as that. It's actually 857142 repeating. If you were to round it off at 4 or 5 or so decimal places, I would accept that on a test. And in my math lab, it almost always tells you to round to the nearest hundredth or nearest thousandth or something like that. Of course, those can get a little worse. (1.9x minus 3.2 plus 0.2x equals 6.4. What do I have to do here?
Add the 1.9 and the 0.2 or subtract.
Well, they're both positive, right?
Right.
And they're both on the same side, so I'm just going to combine them. I'm going to add them. That does become 2.1x. What else is still there?
Negative 0.32.
Negative 3.2 equals 6.4, yes. And what is next? Add the 3.2. So 2.1x equals 9.6. And then? Divide by 2.1. X equals 4.57142857143. Approximately. How would I express that answer? If I didn't tell you to round it, how would I end up expressing that answer? (571,428), and that repeats, yes. Perfect. How's about something like this? Tell me what to do. Careful. There's one thing I should do first. I could do that, but there's one thing I really should do first.
Subtract the 1.4x.
Yeah, so the x appears twice, so I should get rid of one of those x's. So we get rid of the 1.4x by subtracting it. So on the left side, 4.9x minus 1.4 is 3.5x minus the 3.25 equals 9.25. What do we do from there? Now we'll add the 3.25. And we get 3.5x equals not 13, but 12.5. There we go. And then divide by the 3.5. So x is going to equal 3.571428571143. Yeah. Like that. Now there is an alternative here. Rather than writing out these repeated decimals for every answer, I could have expressed each of these as a fraction. For example, here I have 12.5 over 3.5. There's one decimal place in each. So to get rid of the decimals in that fraction, I would multiply both of them by 10. So that becomes 125, and this is 35. 3.5 times 10 is 35. Now there's a couple of different directions I could go from here. I'm going to make it easier on myself. Both of them can be obviously be divided by 5. So I'm going to divide by 5. That gives me 25. 125 divided by 5 is 25. 35 divided by 5 is 7. 7 goes into 25 3 times. That'd be 21, so there's 4 left over. So I could have also, rather than doing 3.571428 repeating, I could have also written that as simply 3 4/7. Could have done the same thing up here. 9.6 divided by 2.1. What do I have to multiply by to get rid of the decimals there? 10, because each is only one decimal place again. So that's 96 over 21. Twenty-one goes into 96 4 times. That would be 84. With 12 left over. So that's 4 and 12 21st. Well, 12 and 21 can both be reduced by 3. So that's 4 and 4/7. So here, what do I need to do? I need to distribute. I see the parentheses. There's nothing to do inside of those parentheses. So now I have to do something to the parentheses. That is multiplying by the 3.1. 3.1 times 2.3 is 7.13x. Good. 3.1 times a negative 5.2.
Negative 16.12.
Negative 16.12. You got it. Equals 21.8. Since the parentheses stopped here, we didn't have to multiply the other side. We stopped multiplying at the end of the parentheses. Now what do we do? we will add the 16.12. So over here we got 7.13x equals 37.92. Then what?
Divide by 7.13.
We can divide by 7.13. X equals, now we could divide that out. We're going to get 5 point something, right? Get back here. 5.31837307. Does not look like anything's going to repeat there, does it? So we're going to go 5.3184, looks like. I'm going to go. Now, what if I had said to express that exactly? If I said answer to the nearest 10,000th, which is what I did here, that would be the correct way to express it. If I said express it exactly, or to give the exact answer, that 5.3184 would not be an exact answer. That is a rounded answer. I don't see a repeating pattern in this one, so I'm not finding a repeating decimal. So the only way to express this exactly would be to go back here and work with it as a fraction. Can I multiply the top and bottom by 10 here? Well, I could, but it wouldn't do what I need it to do, would it? What do I need to multiply both of those by? 100. Why by 100?
Move the decimal all the way to the end.
Yeah, there's 2 decimal places in each, so multiplying by 100 moves the decimal point 2 spots, gets rid of 2 decimal places. The 37.92 times 100 is 3,792. 7.13 times 100 is 713. Now, I don't see anything that those can both be reduced by. So let's go ahead and divide out. $3,792 divided by 713. It's going to go in there 5 times. 5 times 713 would be 3,565. So now I subtract. So I borrowed, that's 12 minus 5 is 7. 8 minus 6 is 2. 7 minus 5 is 2. So there's 227 left over. So that's 5 and 227, 713ths. That's a wee bit ugly. A wee bit. Okay. I'll try to be a little bit nicer than that to you on a test. I think the worst one on a test comes out to some like 23/59ths or something like that. Something weird. Not 713ths at least. I'm going to have you guys try one in your notes. Try that one in your notes quick. Now I'm going to do this. I'm going to add this note here to express exactly, give the exact answer. If it comes out to a repeated decimal, that's fine. Do it as a repeated decimal. Otherwise, convert it to a fraction. What's our first move here? Distribute. We're going to multiply by the 2.3. So 2.3 times 3.4x is 7.82x. Good. 2.3 times negative 2.1. Negative 4.83 equals 11.9. Then what? Add the 4.83. So 7.82x equals 16.73. Good. And then divide by 7.82. It's multiplying, so we have to divide. So x equals. Now, if I divided that out, do I get a repeating pattern of any sort?
No.
Not that we recognize there, no. So let's try it as a fraction. What are we going to have to multiply by? 100 to move it 2 decimal places. So 1,673 over 782. To divide that out, 782 goes into that twice. 2 times 2 is 4. 2 times 8 is 16. So 6 carry the 1. That's 15. So that's 109 left over. So that's 2 and 109 over 782. That is our answer. Any questions? Let me give you one just a little bit friendlier to try. 4.7x minus 3.94 equals 2.3x plus 5.83. I'll give you some time to do that one in your notes. So in this one, what would my first step be?
Subtract the 2.3x.
Perfect. The x appears twice, but it's on each side, so I can't just combine them. I have to get rid of one. So I'm going to subtract the 2.3x from both sides. So this one's gone. Over here, 4.7x minus 2.3x is 2.4x. Nothing else has changed, so that's still minus 3.94. Over here, the 2.3x is gone, so that's just 5.83. Then what? Add the 3.94. So 2.4x equals 9.77. And then divide by 2.4. X equals, now again, 9.77 divided by 2.4 should terminate, actually. Oh, no, it doesn't. But it does give us a repeating pattern, doesn't it? 4.0708333333. So 4.0708 and then the repeating over the 3. Did anybody express it as a decimal like that? Okay, and that is just fine. If I'm asking you to give the exact answer, that should be an exact answer. Now, my math lab may say express as a repeating decimal, or it may say express as a fraction. So if I ask for this as a fraction, how do I have to make sure I do it? Well, what would I have to multiply up here to get rid of the decimals within my fraction? 100. Very good. So 9.77 becomes 977. 2.4 becomes 240. Very good. So now 977 divided by 240. 240 goes in there 3 times. Nope, it goes in there 4 times. That'd be 960. So there's 17 left over. So that's 4 and 17 240ths. What do you think?
How come you don't subtract the 2.3x plus the 5.8x and line it up under the 4.7x? Like in some of those problems where you take the one side and you line it up underneath the left side?
Oh, I did. I subtracted this one here, the 2.3. I subtracted that and I subtracted it off of here.
Some of the problems where you take the whole right side.
Oh, took this number too, you mean?
No, it's because of the equal sign in the middle. That's why. It's
Yeah.
One equals another.
You've explained it to me a million times and I don't.
Okay. Well, I think what you're looking at, and that's exactly the right answer, is because the equal sign is in the middle here. I think the ones you're thinking about look like this.
Because I did that and I got the 2.4x minus 9.77, so I just left it thinking that was it.
You're thinking about something that looks like this.
Let me find it in my notes here.
Because this one you would have to combine the 5x plus 7 and the 2x minus 3. Like that. It's addition, so you would add down the columns in this case. That would give you a positive 4 and a 7 here. The other one I can think of that you might be looking at might look like this.
I think I got it confused with integers operation.
Okay.
You had like a bunch of numbers in parentheses plus a bunch of other numbers in parentheses, and then you line them up underneath each other.
Okay.
And then you got the answer and you left it alone, so there's nothing else you can do. So I think
Sure.
that's what I did.
Okay. I say because the other one I can think of looks like this, where you've got x, y, and 1s on each side. So the x squareds have to, or not x squareds, x's and 1s. So the x squareds have to have the same coefficient, and they do. The x's, we don't know for sure because we've got b and we've got 5. The 1s have the same coefficient, which is the 11. So that tells you that these two have to be the same because that's all that's left. So that b has to equal 5 is what that's telling us. That's something that'll appear in my math lab. They'll give you a couple of questions like that, but I will not put that on a test. If you do happen to come across one of those, just let me know and I'll go through it with you today, tomorrow, or whenever. By the way, just so you know, as a reminder, Our Unit 3 test is coming up this Thursday. That leaves us with exactly 3 weeks left to finish up Unit 4. Unit 4 is our geometry stuff, areas, volumes, missing sides of triangles, and then Unit 4 is kind of a weird unit because there could be a small Unit 5, but in the summer there just isn't time to do 5-unit tests and still get everything covered. So some basic statistics. The last 2 classes will be on some basic statistics at the end of the summer here. That's the reason why you'll notice on the schedule there's absolutely nothing scheduled for that last day of class. I think it's August 4th. We're scheduled to take test 4 actually on August 3rd would be our last day of class. We're scheduled to take test 4 on August 1st, which is that Tuesday. The reason I left August 3rd open is there is a final test we could take. Again, that's not to assess the students, that's to assess the course. But in the summer, we almost never get to that because usually at some point in this 3rd unit, we need to take an extra day to go over things. So usually test 4 gets pushed back to August 3rd, that last day.
Okay.
So that gives you that extra day to study.
I was gonna say Tuesdays.
Well, the disadvantage of having it on August 3rd is, for those of you at the far sites, you gotta when you turn it in, you kind of gotta push the people there to send it, to scan it and email it to me right away, so that I can grade it and get it right back to you, so you can do corrections on it. Otherwise, because I have to have my grades turned in by the end of the day that Friday, so otherwise it gets to be kind of a short turnaround on doing corrections on them. Okay, well, back to business here. It's not quite break time yet. We're going to look, of course, at a couple of word problems with our decimals. Let's say a service call costs $34.75 plus 45 cents per mile. How much would a 48-mile service call cost? So we need to write an expression for the cost of a service call. The cost is going to equal, what's the base cost? The cost that you're going to get charged no matter what? The $34.75, so 34.75. Plus, how would we express 45 cents a mile? $0.45. We'll go M for miles, so times M. So you put in the number of miles and you're going to multiply, right? So now, for a 48-mile service call, all we have to do is put in 38 for M, or 48 for M, for the number of miles. So 0.45 times 48 is $21.60. $34.75 plus the $21.60. Our cost is $56.35. Related to that, on that same pay scale, how many miles would a $60.85 service call be. Up here, we knew the miles and we were finding the cost, right? Down here, we know the cost and we're finding the miles. But it is still the same equation. Cost equals 34.75 plus 0.45 M. The difference is the $60.85 goes in for the cost. Now what do we have to do?
Subtract the 34.75.
Perfect. We subtract the 34.75. Gives us 26.10. And then
Divided by the 0.45.
divide by 0.45. What's that give us? 58 miles? Okay, related to that, I say related, similar to that, we might have a problem like this. A sports supplier sells baseballs for $4.50 each, and bats for $8.25 each. If three times as many balls as bats. Let me do that. Let me go to if they sell three times as many balls as they do bats, for a total of $652.50. How many of each were sold? So here's one where we kind of have to write out and build things up as we go. So we have baseballs and we have bats. And I'm going to start out by trying to express the number sold. One of them is related from the other. I got to be able to express them in one variable. I can't have, X for baseballs and Y for bats. So looking up here, there's a relationship between the two of them given. 3 times as many balls as bats. So which one is going to be X? Which one sold less? The bats. The balls then would be 3X, 3 times X. Now they didn't give us the total number of items sold. If they did, if they were to tell us that they sold 480 total items, will be 3x plus x equals 480. But we didn't get the total number of items sold. They gave us the total dollar amount. That total dollar amount is the $652.50. Well, how do I express the dollar amount of baseballs sold? That's price times the number sold. So for baseballs, there's 3x sold. What was the price? $450. So it's $450 times 3x, which comes out to be 13.5x. For bats, how would I express that? You got it. X times 825, which is 8.25x. Those are the two numbers that have to add up to the total dollar amount of $652.50. So 13.5x plus 8.25x equals $652.50. Then what?
Combine the x's.
We combine the x's. There we go. There we go. Sorry. 13.5 plus 8.25 is 21.75x equals $652.50. And then
Divide by the 21.75.
divide by 21.75. X equals 652.5 divided by 21.75. I get 30. All done? No, I have to answer the question, right? X is the number of bats. There were 30 bats. But I still have to do the baseballs, which is 3x. So 3 times 30 is 90 baseballs. Now, to kind of lead us into our break here, I'm going to outline a very similar problem. So baseballs are still going to sell for $4.50. Bats are still going to sell for $8.25. A total of 240 items sells for $1,305. How many of each sold? We're a minute early for break, but we're going to go ahead and take it anyway. We're going to come back and start lecturing at 10:30, but I want you to come back and use that extra minute to see if you can lay out this problem. So that's where we'll start when we come back from break.